here is the power rule. So this right here means d over dx means we're taking the derivative. So if we're taking the derivative of a variable raised to a power, okay, you can do limit definition of a derivative, or you multiply out front by the coefficient and you decrease the exponent by 1. Okay, here's what it looks like. Okay, we could do the whole limit definition of a derivative. Oops, I don't know that. We could do the whole limit definition of a derivative. It'd take us forever to do. Or we can simply say, like for this problem, f prime of x would be 3x squared. If you did limit definition of a derivative, you would go through the whole thing. This is what you would get. You multiply out front by the 3, which there's nothing there, so it's like 3 times 1. Decrease your exponent by 1. 3x squared. So who wants to try number 2 for me? What is f prime of x for number 2? 20x to the 4th. I know, it's mean, isn't it? It is because, number 1, they ask us some questions about limit definition of a derivative, and they pose them in such a way that you at least have to know that that's what it is. Number 2, I do want you to understand, like that limit definition of a derivative, you're looking at that limit of a slope, so you're looking at that slope as it gets like closer to that point is what's happening, because that's like the math theory behind it. Okay, but super duper easy, right? As far as figuring this out, we could teach 4th and 5th graders how to do it. They wouldn't understand what they're doing, but anybody who can multiply and subtract should be able to follow this rule if we needed to, right? So there is a constant rule. The constant rule tells us that the derivative of any constant is 0. If you think about it, like if I'm trying to take the derivative of 7, right? It doesn't have any x's, right? So if it had an x with it, what would the exponent on that x be? It'd be a 0 because there's really not any. So if I just have 7, now if I wrote an x there, it would have a 1. But like if I just have 7, that's the same as 7x to the 0. You could follow the power rule. 7 times 0 is 0, x to the negative 1. But does that x to the negative 1 matter whenever you're multiplying it by 0? It's just 0, right? So if you're ever taking the derivative of a constant, just a number without an x at all, it is just 0. Okay? If you have some more properties of derivatives, if you have the derivative of 2 times f of x, it's just going to be 2 times f prime of x, right? That scalar multiple just kind of stays out front. This was similar with limits. If we were doing a limit of 3 times some function, we just did 3 times whatever that limit was. If we have a sum and difference, so if we have different pieces added or subtracted together, I guess I should put a plus or minus right there. Then we just take the derivative of those pieces separately. So everything that's separated out by plus or minus signs, we just take the derivative of those separately. So let's look at what we've got here. So if we have f of x equals 3x to the 4th minus 6x squared plus 3x minus 1, and we're taking the derivative, we just do each term separately, right? So 3x to the 4th would be 12x to the 3rd, right? Just multiply. 4 times 3 is 12. Subtract 1 from your exponent, you get x to the 3rd. We'll get minus 12x to the 1st power, but we don't have to write that 1, plus 3, and then that derivative of that negative 1 is just 0. So 12x to the 3rd minus 12x plus 3 would be our derivative. Does that make sense? Okay. Oh, and what would the derivative be for number 2? Very good. Okay, so it's just that quick algorithm that you're doing for that. What about number 3? Is not 0. Is not 1/5. It is not 1 over 5x to the 4th. So for us to apply the power rule, we have to have it in the form of x to the n power. It can't be in the bottom of a fraction. But we could rewrite this, right? So we could, instead of doing 1 over x to the 5th, we could call it x to the negative 5th power, right? If we have stuff in the denominator, we can move it back up to the numerator and just give it a negative exponent. And the 1 is still there. You can put it there if you want. As far as this y right here goes, there's 2 ways you can write this. You can call it y prime, or you can do dy over dx. Both of those are notations that we use for taking the derivative of y. I'm just putting them, I don't care which one you use, you just may see either one there. So if we're taking the derivative, the power rule is still the same. Negative 5 times this 1 out here is just going to be negative 5. X to the what power? Not negative 4. It feels like it should be negative 4, but it's negative 6 because we're subtracting 1 from the exponent. Be careful with those negatives. You may see your answer left like this, or they may move it back down. They may move that exponent back down to the denominator and write it like this. Only the x goes to the bottom. That 5, the exponent only goes with this x right here. It does not go with the 5. So you'd have negative 5 over y to the 6. Oh, I don't know why I wrote a y. That should be an x. Good question, Troy. I'm losing my mind. X to 6, thank you. All right, so similar to number 3, number 4 also cannot be done like it is right now. How could we write that so it would just be x to a power? We cannot cube it. We can't do it. We can only just rewrite. We can't this is not like an equation where we're like doing something to both sides. Because if we cube this side, we'd have to cube the f of x. And then we'd have f of x cubed, and that would be complicated, right? It is x to the 1/3 power. Whenever you are doing rational exponents, the exponent on the inside goes on top of the fraction. Whatever type of root you have goes on the bottom, right? Roots go on the bottom of a tree, so roots go on the bottom of the fraction whenever you rewrite this. So the rule there is, like if you have the r root of x to the a power, it's x to the a over r. So if you have square root, any type of root, you want to rewrite it with a fractional exponent. Then you're going to take the derivative using that same rule. Okay? So multiply out front by the exponent, 1/3 x. I've got to subtract 1 from the exponent. What's that going to give me? Negative 2/3, because I'm doing 1/3 minus 1. You got to have common denominators, so you multiply by 3 on top and bottom, right? You got 1/3 minus 3/3, which gives you the negative 2/3. Now, they might leave the answer like this. Now that you got a negative exponent, they may move that back down to the bottom. And they may change it back to a root. So 3 cube root of x squared. As far as free response goes, like on an FRQ, if you have something, just leave it right there if you don't need to do anything else with it. But on multiple choice, they may change it back to any grade of things, so you need to know how to do that as well. Okay, questions? we are taking our exponent and we are subtracting 1 from it because that's what our rule tells us to do. It's really easy when we have whole numbers, right? We're just doing 9 times 5 is 45, and we're doing 5 minus 1, which gives us 4. All right, same thing here. We're multiplying -5, then we do -5 minus 1, which gives us -6. So that rule is still the same even when you got fractions. It's just your answers are going to be a little bit more complicated. Sometimes you might need to do the work over to the side for those. Yes? It's the 1/3 right there. So since that's a fraction, like I could put this over 1 as well if I want. I'm moving this back down to the bottom there, so that's where that comes from. Okay. Any other questions there? All right. Okay, so if we are asked to do something like find the slope of the graph at these different points, this is going to make this question much easier to do because we don't have to use limit definition of a derivative. So if I want the slope of the graph at a point, that's the derivative. The derivative is what gives me slope. That should be a question everybody should be able to answer really well and understand that derivative gives the slope of the line, right? Or slope of the tangent line at that point, which is our slope. So if we're asking for a slope of the graph, it is looking for derivative. So the first thing we would do is just find our derivative here. So we find f prime of x. Smith, what would f prime of x be for this particular problem? Perfect. Okay. And then once I have this, if I want to know the slope at a specific point, rather than having to do that top limit definition, I can just plug the number into my derivative. So I do f prime of 1. Make sure when you're doing this that you label it because we need to know you plugged 1 into the derivative. So 9 times 1 squared minus 8 times 1, that's just going to be 9 minus 8, which will give us 1. So the slope of f of x at 1 is 1. At 0, we would just plug in 0. So we would get 9 times 0 squared minus 8 times 0, which will give us 0. And for -2, we would just plug in -2. And we would get 9 times -2 squared minus 8 times -2. And so that would give us 9 times 4. Make sure you do exponents first there. Plus 16. So 36 plus 16 is going to give us 52 for our derivative there. So the slope at -2 is 52. That's a very steep slope. Your graph would be very steep at that point. Yeah, it's basically going to look like a vertical line at that point. Yes? So things that are, so right now some things you cannot use shortcut for, because that's a good question. If you have something like this, if you have, so no shortcut for this. If I have something like this, x plus 1 squared times x minus 2, technically I can use the shortcut, but only if I expand that out first. Okay, so you would have to expand that out. If I have something like f of x equals square root of 1 plus 6x, can't do it. Because you've got a root, you could write it like this, 1 plus 6x to the 1/2 power, but you can't like distribute that 1/2 there. It's an exponent, it's not a coefficient. So there's going to have to be another rule that we learn about for that. If you have something like this, x plus 2 over x minus 7, something like that, where we've got variables in numerator and denominator, we're not going to be able to use the shortcut for that either. There are other rules that we're going to learn for those. You pretty much, other than the questions, the AP words as limit definition, we are going to learn rules for doing almost every derivative, but these are ones that we don't know yet. This is only going to apply if you can write it as x raised to a power, right? If we can get it to be written as x raised to a power, then we can use the shortcut rule. And this particular shortcut rule, the name of it is the power rule. There will be other shortcut rules that we will learn next week. All right, so here's a tangent line problem. So this is like you were seeing on your FRQs, right? What two things did I say we need for a tangent line?
Slope and point.
We need a slope and a point. Right, we got to find those two things, and then we can write our equation of our tangent line. So let's start with the point first. What do I have to do to find the point? Plug in 1 to the original. So to f of x, we're looking for f of 1. So if I do f of 1 here, it's going to be 1 over 1 squared, which is 1. Okay? That tells me that 1, 1 is my point for my line. It's my point of tangency. Okay? Then I need to do the slope. What do I find for the slope? Derivative. F prime of 1 is what I'm looking for slope. So before I can do the derivative, this one is not written as just an x to a power. How do I rewrite that so that it is just x to a power? Not 1/2. X to the negative 2. Roots are where we're going to end up with like 1/2. If it's just in the denominator, it's just going to be moved up to the top with a negative exponent. Notice here, I named this f of x. I did not call it f prime of x. I have not taken the derivative yet, right? This is equivalent to this, so I have named this f of x. Now I want to take the derivative, so I'm going to call it f prime of x. For that, Lucian, what's the derivative of that going to be? No. Well, you may be. I don't think so. Are you plugging in a number already, or are you? So when we take just the derivative of x to the negative 2, what will we get? Very good. And you don't have to move that back down to the bottom, but it's going to be easier to plug a number into if we just move that negative exponent back down to the bottom. So we will have negative 2 over x to the third if we do that. Everybody good there? We want to plug in 1, so we will get negative 2 over 1 to the third. I think you may have made a mistake, Lucian. What is 1 to the third? 1. And so we should get negative 2 for that. That is my slope. Well, I should have circled it. That's not my final answer. So once I have a point and a slope, I'm using y equals m times x minus x1 plus y1, right? So y equals negative 2 times x minus 1 plus 1. That would be my equation of tangent line. All right there? Yeah, if it asks for the y-intercept like that other one, then we would have to distribute. If it just asks for the equation of tangent line, stop here. There's no need to simplify. But if it asks for the y-intercept, you would have negative 2x plus 2 plus 1, and y would equal negative 2x plus 3. And so the y-intercept would be 0, 3, if it were asking for that. What if it only asked for the slope of the tangent line? It'd just be negative 2. You would have stopped right. You wouldn't have even had to find the point. You would just, so if you get one that only asks you for the slope of the tangent line, then you just have to find the derivative and plug that number in. You don't have to do the whole equation. Okay, everybody good there? Okay. All right, so here's a pumpkin chunking problem. You guys had Miss Ball for this, so I don't know if did you guys make catapults and do? I always let my Math 1 kids make catapults and we shoot our pumpkins. But a pumpkin is launched from a height of 15 feet with an initial upward velocity of 60 feet per second. This equation right here is the equation that you use for the height of a projectile object. Now, it does ignore air resistance, so this would be like shooting, and it must be on Earth. It would be like shooting a pumpkin in a vacuum, but still on Earth. Well, yeah. So you still have gravity, but you don't have air resistance. Now, for something like a pumpkin, air resistance is going to be lower because it's a fairly dense object, so you can still get a relatively close estimate here. If you were launching something like a flying squirrel from this particular cannon, it would not be so accurate because they have a lot of air resistance and would not follow this as well. But for relatively dense objects, ignoring air resistance, this is your height. So for this particular equation, your height would equal negative 16t squared plus b sub 0. That is initial upward velocity, which they tell us is 60, so we'll have 60t. And h sub 0 is initial height, which is 15. Okay, so if they ask for the average speed, and actually I'm going to call this h of t. It's just easier for notation-wise if we call it h of t. If they ask for the average speed of the pumpkin from 0 to 1, then what we would do for that is that would be the slope through the endpoints, right? 0 something and 1 something, right? So h of 0 here, if I plug that in, I'll get zeros right here. I'm just going to get 15. And that should make sense. That's my initial height, right? H of 1 would be negative 16 times 1 squared plus 60 times 1 plus 15. So it's going to be 75 minus 16, 59, I think. I'll do that right. This calculator speed us up a little bit. Okay, so we would just, if we're wanting average speed, we would just do slope. 59 minus 15 over 1 minus 0. And so 59 minus 15 would be 44 over 1, so 44 feet per second. Okay. B asks what is the instantaneous velocity of the pumpkin at t equals 1. Okay. So if we're wanting instantaneous velocity, right, if we have a height function, then we are talking about the velocity of that function. So if we think about our h of t, we would have time here and height here. This is measured in feet. This is measured in seconds. So if I want to know feet per second, that's taking my y-axis and dividing it by my x-axis, which is my change in y over my change in x. That's the slope of this graph, right? So when it's asking for velocity, velocity is our slope of position, or in this case, height. And how do we find slope at a point? How do we find the slope? Derivative, right? So if we want to find the instantaneous velocity of this, we would do the derivative, h prime of t, which would be negative 32t plus 60. And if I want to know that instantaneous velocity at 1, h prime of 1 would be negative 32 times 1 plus 60, which is going to give me 28 feet per second. Slower than the average, because what happens to that pumpkin as soon as it would leave whatever you're shooting it out of? It starts slowing down, right? It's going the fastest whenever it leaves the pumpkin until it gets to the very top. And then it's going to fall, and gravity's going to make it fall faster and faster and faster there. Mm-hmm. When you take the derivative of a constant function, it's just 0. Because like it doesn't have a t, but if it did, I'd have to put t to the 0. So when I do the power rule, I'd have to do 0 times 15 and make that go away. It'd be 0. So any constant number without a variable is just going to go away whenever you take the derivative. It's a good question. Okay, we are not going to do C for the sake of time right now. So, all right, let me look at this and see if this is still what I'm wanting. I know this is a lot of questions, but they should take seconds to do. They should not take long.
These guys?
Yeah. This should be, like, easier than 5
I think we should just do 3.
limit definition of a derivative.
That's like 50 questions.
It's not 50 questions.
I think it's like 60. I think it's like 89.
It couldn't possibly be 50 questions,
It
guys.
is 89 questions.
All right. Yeah. Yeah, those are easy peasy.
How many questions is it? It's like,
25 to 29.
Seven.
That's not bad.
9, 4.
39. Oh. Okay, we did not do one like this. Let's do, let's see, what's 55 and 56? I may not want you to do that yet because we didn't spend as much time. All right. Okay, let's look at 41. If you want to put this at the top of your homework, it's fine if they're out of order. You got f of x equals 4x cubed plus 3x squared over x. This looks like one I told you we can't do yet, right? Because we got x's in top, x's in bottom. And as it's written, we can't do it yet. But we could do the love connection here. I taught you guys about a love connection in math in pre-cal, didn't I? We can divide both of those terms in the bottom by that x. So that would mean that we got 4x to the third over x plus 3x squared over x. So that's 4x squared plus 3x. Now, I haven't taken the derivative yet. That's just rewriting. Okay, here. All right, so the derivative then, Kendall, what would the derivative be for that one? Okay, so if you see one that's division like that, do the love connection with each one. I think everything else is stuff that we've looked at. You should be okay on that. Okay, all right. So if you guys will make sure your phones are back there for me. It looks like there's a few of them missing.